So you should potentially be seeing on your end the air meet starting to come live and me here, Austin. Let me see if I can drag you in while I still have you on the call, actually, because I can't figure out how to do that. If you don't mind sending a message in the open chat. Hey, Austin, do I still got you? Cool. Let's see. So you sent a message in the chat. I don't know how to add you to the stage. Hey there. I think we got maybe Tommaso on the line.
How are you, Dan?
Oh, I'm doing okay. We're setting up. We're live now, but I cannot, well, no matter what I do, get Austin onto the stage.
Who's that?
Austin is our presenter today.
Okay, fantastic. Let me try this. Austin, invite to stage. 3, 2, 1, done.
Awesome. I just didn't see the setting.
No worries. Good to see you, Dan. How are you?
Doing quite well.
Austin!
Good to see you too, Austin.
Good to see you.
Yeah. Thanks for having me. I'm here.
Exciting.
We did it. We had to do it live, but we got it to work.
Got it to
We're
work.
gonna do a lot live tonight. I'm for my presentation. It'll be lots of live stuff.
Actually, this cool. Experiment that we just did, right, is to prove that it is live, right? Because otherwise it would say, no, it's not live, it's recorded, right? I said, no, right. It's live. You saw that we have some hiccups and we solved it.
Exactly.
For sure.
I like solving tech issues. You'll have to show me how to do the one stupid thing I missed on bringing somebody onto stage next time, Tommaso.
I see here Timothy maybe might be also wanting to join.
Great. Yes, we should get him in.
Okay, done.
Hello.
Hey, Tim.
Hey. How are things over at the classroom tonight?
So far there is nobody here.
It's not too much.
I think people will be showing up later.
Yeah, that'll work. That'll work. I figure it's okay. We could probably pause and wait for a little bit of time. And I think we can even pause the section live. I will not end it, though.
Yes,
so I'll go ahead and do that for now. Hopefully we don't kick.
Yeah.
Yeah.
I love the dance.
Rock on, rock on. So I won't give Austin too much of an introduction, but a little bit of a backstory. Like Austin and I met a few years ago at Wyoming Hackathon. I think was the first time we got to hang out together, and was just getting introduced to Ethereum at the time. And since then, Austin's portfolio, I think I linked in the announcements for you guys to check out, has really exploded. It's accelerated exponentially and doing a lot of amazing work, in my opinion, and I think in a lot of people's opinion, around education in Web3 in general and Ethereum like dev core tooling. So like I think tonight is going to be really special to see some of the work that he's been doing and give you some real tools of the trade that a lot of people lean on, and is to like rapid exploration of ideas and maybe some rapid prototyping of some dApps. So with that, maybe I'll let you take it away, Austin.
Sounds great. Thanks for having me. Yeah, so let's Dan, thank you. Like I said, in the background you have your painting. I have the same painting. It's you don't see a lot of people IRL these days, so yeah. I can appreciate
you gotta love the Ethereum art.
Word,
cool, man.
Word. Well, thank you for having me. I think I'll just probably like share my screen and we can get started. It would be great if like I could get more feedback, so feel free to like YOLO questions into the chat or whatever. It sounds kind of like a good portion of folks like have Ethereum and understand Ethereum or understand blockchain. Is that true? Like do I like I have a slide that explains like WTF is blockchain. I probably can skip some of that stuff and we can start talking about what works and what doesn't work on top of Ethereum. Is that probably more of a better way to zoom in? Okay, I'm seeing some thumbs out there. Cool.
Yeah.
All right. So yeah, in that case, I'm going to ditch my WTF is blockchain stuff, which is here. Let me move this over here. Okay, so we don't need to know what the fuck is blockchain. And really, like the TLDR is like, it looks a lot more like that, right? It's about decentralization. When we talk about what is Web3 and what's most important about Web3, it's this decentralization, this idea that this thing can't be stopped. If you write a smart contract correctly, it should never even you couldn't destroy it, right? Then then I want to talk about this. Who knows? Let's see. I can't see a whole lot of people out there, but raise your hand if you know what the Pixelmon Kevins are. This is probably new within the last like 24 to 48 hours. But there was like an NFT drop, and I think it was kind of disappointing to some folks, but these ones were like so particularly disappointing that they're worth like $14,000 now. So just wanted to share this. This is a very weird corner of, of the internet here, weird NFTs. And one thing that's really interesting here is that I could deploy this exact same NFT in a smart contract and it wouldn't have this kind of value. The market really decides what's valuable and why it's valuable. And so that's something that as you're trying to figure out your own product and product market fit, it really is like it's a trick of like finding out what the market likes in a lot of ways too. And they like the Kevins. Look at those beautiful Kevins. Okay, so on Ethereum, because it is decentralized, because it is permissionless, basically anybody can deploy anything. So you are going to have scams, you're going to have weird things, but there's also a really powerful kind of substrate, a network that we're deploying on top of. And that's kind of what I want to explore tonight, but also explore kind of some tools to sort of dance around on that network. So just quick TLDR, Ethereum is great for deploying decentralized apps. It's a smart contract platform. Before Ethereum, if you wanted to build a decentralized app, you basically had to build the entire peer-to-peer network and set up, the economic incentives for people to mine and do all of that. With Ethereum, it's sort of like the network takes care of itself. It's at a protocol level. There's a lot of gigabrains figuring out how to make it work. And for us, we get to deploy smart contracts on top of it. And it's actually like smart contracts are pretty simple code. If you're an okay programmer, you can pick up smart contract programming pretty quickly. It's similar to almost like embedded controllers, right? Like you have to understand what the bits are doing underneath there, and you have to understand like every little memory that we're using here is very, very expensive because it's not just on one machine, it's stored on all the machines all across the network. Whenever you deploy a smart contract, it isn't just going to one machine, it's going to all the machines. Okay, so let me dive into what I want to do first is just tinker around with eth.build, but also like shout out questions if you have them as we go. But eth.build is, you can go to eth.build and there's kind of a curriculum here. It's older now, but it's still pretty relevant here. And of course, you guys know what hash functions are and kind of a lot of the concepts here, but I still want to show them off because this is like a good place to tinker around with things. So an account on Ethereum is basically this private key right here. Is that big enough? How big do I need to make that so that shows up there where you guys can see? Can you see the, maybe that'll work? I'm hoping we can see. Okay.
Yep.
Great.
Thanks.
Great. And feel free. Oh, there's another chat. So I was watching a different chat. Hold on. Let me jump and make sure if anybody has hit me with any chat. Yes. So each of those sold for 3 ETH at the start. Yeah. Yep. Okay. So nothing big in the chat. Okay. I'm going to keep going. So eth.build kind of lets you play around with some of these concepts in a very visceral kind of like wire it up kind of way. So this is basically what makes your account on Ethereum, right? That private key. And I know you guys have gone through some cryptography and some stuff already. You probably know more about it than I do, but just kind of quickly covering it. You've got the 64 character hex string, and that hex string can actually be used to do something really interesting. It can be used to sign a message, right? That private key can wire up and sign some message. Let's say hello world. And what that outputs along with the message is a signature. And that can go across the network, right? This can basically go across a public network. And if it's tampered with, it's just going to break on the other side. It's not going to work. But if on the other side, everything comes through fine, you can take that message and that signature and you can recover who the person was that signed it. See, it's that same address that is connected to that private key. And this is kind of like the trick that happens on a distributed ledger. Basically, Alice wants to send money to Bob. So what Alice can do is use this key pair, this ECDSA key pair, and sign a message that says, I would like to send $5 to Bob, and you have a nonce, so you have replay protection, and that goes across the network. And if anybody tampers with it, then it doesn't, on the other side, it doesn't recover correctly. But if you get it correctly on the other side, you can recover it and say, sure enough, like Alice does want to send that money to Bob. And so that, in combination with proof of work, is sort of like what's going on kind of on this blockchain layer. And we're less concerned about the blockchain layer, but I want to show this. The other thing I want to do is just to talk about like good wallet hygiene and where you should be like kind of storing these things. So an easier way to set up your account instead of tracking things by private keys is to use a mnemonic, right? A 12-word seed phrase. And a 12-word seed phrase can be indexed. Let's see if it'll let me. Yep. So I can do index 0, and that'll give me a private key. Okay. So now this is kind of wired up strange, but basically I've got my 12-word seed phrase, which is producing this private key at this index. So as I go 1 and change it, it changes the account. 2, it should change the account. Yep. 3. So with a single mnemonic, you can index through it and you can have a whole bunch of accounts. And that's basically what your MetaMask is doing. Hopefully y'all out there in the crowd have a MetaMask, but if not, let me expose you to that at least. It's a browser extension that's going to store this 12-word seed phrase for you and then basically use it to have lots of different accounts. So I can open up my MetaMask here and I can select different accounts within my MetaMask. And what that's doing here is just incrementing, like it's just a different index of that mnemonic. And so this is a much easier way to store a nice big set of accounts, and you can have a mnemonic, and we can get into all sorts of like different ways to store it and hardware wallets. But at the end of the day, probably the safest place to store it is in like a smart contract wallet. And we can get into that in a little bit. But thinking of things like a multi-signature wallet where it takes, 3 different addresses to sign a message, then you can have 3 different key pairs in different places owned by different people. And so if something leaks, then that whole multi-sig doesn't leak. So just some good wallet hygiene there, and kind of going over how that works, and also just showing it off here in eth.build so you can get in here and play around with that stuff. I use it a lot for like ETH to weigh and little kind of like just little dashboards. But let's get into what we can do with like blockchain stuff. Anybody out there? I think we're good. Feel free to ask questions. Like for sure, YOLO some questions at me as they come up. But let's get into and like look at some blockchain stuff here. So we can go and basically get the current block number of Ethereum. It's trying to take it from Gwei. It's trying to do something nice there. But so yeah, and if we were to go to look at Etherscan, we'd probably see that that's the same. We're about 14,30500. That's a nice big round number. Yeah. So actually this node's a little bit ahead of it. And really I could like copy and paste this, and we could select a different block here, or we can select a different chain. So I actually have like a local chain running right here. I could talk to that chain instead of talking to MetaMask, or instead of talking to Infura or whatever I'm talking to here. So that brings up kind of another point. What this network looks like, right? It's like thousands of nodes all across the network. They all have the state, and I have one right here. And so if I want to know what the value of a smart contract is or what someone's balance is, I can just ask that node right there, right? And a lot of us are asking Infura, which is kind of just a service that provides, it's an RPC service or Alchemy, but it's more decentralized if you can ask, your local node here. Let me see if I can pull up just another chain, and we could ask it. Let's see. I think I have one for ETH. Oh, it's not going to. I bet it's not. I bet it's like way behind. Let's see. Oh, it's not. It's not even responding. Let's see. Is there? I think I had a RPC for scaffold-eth too. Yeah, I don't have a good example here. I basically all my chains are not going to be responding. Actually, it's just slow. It's just behind. No, it's not. It's not responding. Okay. So yeah,
I
go
was
ahead.
just noticing this is a pretty awesome tool that you're able to select literally any Ethereum compliant endpoint, right? So for the devs in the audience, if you want to use this tool and you know of an endpoint, that custom RPC right there, you can just start hacking on with this drag and drop editor and deploy out to any node anywhere, including a local node, right?
Yep. Yeah, exactly. Yeah. Let's actually send a transaction. That would be kind of fun here. Let me bring in my MetaMask if I can, and we'll unlock it. And then that should be my address. Yep. And also, hey, you can do ENS, right? If I wanted to say what is the name of that address, does that do that? It does not. Oh no, it would be here. It is not. Let's try it the other way around. If we wanted to go from Austin Griffith.eth, does that give me an address? There we go. Yeah, same address. I don't know why it's not going the other direction. That would be great if you could reverse look this up, right? I don't know why that's not. Nope. Okay. ENS is broken. But lots of little tools here where I bet we could even find the price of. Ooh, is this going to tell us the price of DAI right now? Nope, that's not. I wonder if that endpoint being down is not going to work. Okay. Anyways, here is my MetaMask, right? Which is going out to my browser extension, which is holding that mnemonic for me. And if I want to trigger a transaction, I could do something like, let's see, if we wanted to do here, let's do this, a send, right? And then that send can go to, we need a to address, then an amount. So let's see, man, are we gonna really, maybe we should do this on Rinkeby. Let's see. So a test net that's similar to Ethereum. If I go, I don't know why I'm having a hard time finding a chain here. We bring up this chain here and let's select a test network just to not like do this live and send a bunch of money. So let's see what we should see this change. Rinkeby should be on a completely different. Yeah, there we go. Okay. And then if I wanted to check the balance of my address on Rinkeby, let's see, there we go. So I have a whole, or on Kovan, I have a whole bunch of Kovan. So then let's, I'm going to need to put my wallet over here on Kovan just to be safe. Yep. Let's send some Kovan to some address. That would be fun. There we go. That's fun. Okay. So here's what we're going to do. We're going to create an address by just randomly rolling the dice here. Okay. And we could sit here and roll the dice forever and never find an account with a balance on it. Right. So here we are basically, we're constantly checking. Okay. So I'm just like making a new address and I'm looking up the balance on it like that fast. Like I could do that forever and we're never going to find an account with any balance on it, right? So let's send some ETH to this address though, and let's see the balance show up. So let's get a good blocky going there. Okay, green and yellow kind of looks like a little dragon. There's the private key if anybody wanted to steal it. You'd have to be quick. So there is the address. So if I want to copy that address, I'm going to put that into the to address, right? So we'll send it, we'll go to that one. And I'm just going to say 0.001. I think it's going to take it two-way, but if not, it'll break on us and we'll figure that out in a second. Then let me hook up a button here.
So Austin, I also see in the audience, I called out that somebody's got a Kovan address if you want to send it to somewhere.
Nice.
You know where it's at.
Nice. Heck yeah. Yeah. I'll send some there too. Here, let me paste that address in so I have it. Let's see. So that your address is that right there. We'll send some there too. Okay, now let me see what happens when I trigger this. There we go. So when I hit go, it's going to trigger a transaction to send $2 in Kovan to that address. Okay, so let me wire up your to address also, and I'll send you some Kovan also. Actually, I'm going to send you like one Kovan, like a respectable amount of Kovan. Make sure we're not on mainnet, and then hit send. There we go. So I'm able to kind of tinker around here and play around with accounts, kind of created this a new account. Now, hopefully, this dude should have a balance here in a little bit. Is it still? It's still reading 0. Let's see. Let's take it out to Kovan Etherscan and see. Yeah, so he should have 0.001 ETH now. I wonder if this is messing up. Let's see. Let's grab balance of this address. Go. Yeah, there it is, 0.001. Okay, so the very like visceral way to kind of like wire stuff up and play with stuff. Anytime you get like very far into an ETH build, it just becomes this giant mess. Let me go ahead and like clear this and just go through some of this stuff from the curriculum. You can. We should have talked about this a second. You can't. So sign and recover is really like what you're going to be using that ECDSA key pair for. But you can technically use that ECDSA to encrypt and decrypt. But instead of using, so for sign and recover, you use the private key to sign and you recover back to the public address. You'll use the public key to encrypt. So you'll encrypt something with someone's public key, and then they'll use their private key to decrypt it. But all the GigaBrains, probably people on this call have told me that it's not great to use ECDSA key pairs for encryption, but it's technically possible, but probably don't use it. That's you guys are the GigaBrains. You have GigaBrains all around you. You can figure out maybe why that's not a good curve to do that with, but that is there. Let's see. We went through some Web3 stuff. We can play around with this stuff. Yep, go ahead.
So Austin, we had a question in the audience.
Yeah.
So the sandbox tool, do you use it just to basically learn, or do you actually use this to in actual development?
I use it. So I use it all the time for something like, let's go look at Etherscan again. Or maybe the Pixelmon contract or something like that. Let's go back to the Kevins. So I use it a lot to talk to contracts. I don't even know the pixels. What is this? Okay, so this is probably some garbage, but I'm going to get in here and we're going to go look at this contract. So what you can do is, if the contract is verified, I'll use it to grab.
Looks like maybe it's not.
Yeah, well, I'm looking for the ABI. I think it's here somewhere, right? Where do you get the ABI? Oh, I bet I have to go here and then contract. There we go. Okay, so here's the code. So what I can do here is I can grab the ABI for this contract and put that into eth.build in a text box. Okay, and then we'll need to parse that to an object. And now that's basically like a parsed JSON object, right? And then I'll need a text box for the address of this contract. Let's go grab that here. And notice, like, you can see the blocky. See how it's kind of like teal and purple? We should see that same thing here. Yeah, there it is. Okay, so then what I can do is say, I want to talk to a contract. And for blockchain, I think I just gonna leave it. I think I can leave blockchain empty and it will be mainnet. But here's what I actually use it for a lot. Is there now I'm connected to that contract and I can go look at things like, okay, what is the symbol of this contract? TPIX, very cool, very cool. But I'm looking for maybe like some kind of, we could go see the owner of, like who owns, oh, do I need a number? Who owns number 3? The token ID that should give us an address. Oh, nobody owns it. Oh, there it is. There's the person. Will it even give us a nice preview? Yeah. So sometimes I get in here and I'm like, maybe I want to call the mint function. Oh, totally. Right. So if I want to call the mint function on this contract and there isn't a front end available for it yet, you could totally like do that here in Etherscan, but maybe I want to like build a dashboard and share it with my friends, or like make a nice, like really easy button to hit that. But this is like very, very rapid prototyping. Like if it's longer than 24 hours, I'm usually not building a dashboard. I'm building an actual app around the thing. Mm-hmm. But if a contract comes out within like 2 hours and there's nothing to talk to that contract yet, eth.build can be helpful for that.
So I think, as I see contextually, that eth.build is a great way to learn. But on the other side, the flip side, for a power user like yourself, Austin, this is like okay, there's something brand new and no one's built the front end. I can build a minimum viable interactive GUI and ship it out to friends to like interact with this, or just probe stuff very, very rapidly. So as a dev tool, I think it's a great power user tool. But for everyone in the context of this class, I think it's probably more along the lines of you want to play with some ideas, right?
Yep.
Maybe
Exactly.
here you've got some idea of like what structure you'd like, and literally you can drag and drop and connect the dots between the architecture of the contract that you'd like to build, right? That's more, I think, what we can use in this class is that kind of an example. Is think about the contract you want to build and see if it would even like kind of work logically here, and if it does, then you can jump more into the scaffold side of things where you can actually frame it out properly.
And I think that like we probably should jump into scaffold-eth here pretty soon. I wanted to show eth.build and get like some exposure to folks, but really like a lot of the prototyping that we'll do, and a lot of like when we're talking about actually building a product or building something to put into someone's hands, you don't usually want to give them an eth.build. You probably want to give them like a URL they can go to. And so the kind of the back half of this talk will be, okay, you've tinkered around, let's get into smart contracts and let's get into building an app. One other thing I want to show real quick, though, kind of leaning into the education thing that you're saying here. There's a lot more education here of just like tinkering and kind of testing your assumptions. Let me show off. There's a specific one about, yeah, the Byzantine generals. Look at this one. Is so it's really busy, but what it is there's all these soldier modules, and they're kind of reporting to a lieutenant who reports to a lieutenant. And so if we were to get into any of these soldiers, so basically what we have here is it's a demonstration of proof of work. We have General Bob here, and he wants to attack at dawn, right? But what he has to do is provide basically a nonce, this big number right here. It's probably hard to see, but he's looking for a giant number here that hashes with the rest of this message and also produces some leading zeros. So basically some arbitrary work. And so if we get into one of these soldiers and look at them closely, what they're doing is they're taking Bob's message and they're working on it by just like slamming hashes as fast as they can, hoping to find one with leading zeros. And now and then one of the soldiers finds one with leading zeros and passes it up to Bob, and we'll see it here. So what Bob can do is say, well, you know, I need to prove that I have an ability to wage war or whatever. Not a great thing to be talking about right now, but the Byzantine general problem talks about how without communication, they need to coordinate and attack at the right time. If they don't attack at the same time, then they'll lose. So figuring out how to prove that you have the ability to attack and prove to other generals that they should attack at a certain time. And the way it is Bob will say, well, we should, you know, attack Tuesday, Tuesday at noon, right? Maybe he changes his plans. But what he has is all these workers working super hard round the clock to find a leading zero. And there it is. He found one already. So basically 3 leading zeros is too easy. If we wanted to really be attacking at dawn and we wanted to really coordinate, maybe we'd need 6 leading zeros, right? You'd really have to have a huge army and have it arbitrarily hard to have just the generals be able to communicate with each other with this sort of proof of work. So super weird, like cool, fun example to get into with eth.build. Jump on eth.build or eth.build, and you can kind of go through, you know, from the beginning all the way to smart contracts. But if we're really, I mean, look at that bozo. If we're really getting into smart contracts, I think probably the next step is here with scaffold-eth, and I think I can show that off next. But maybe I'll pause for a second and see where we are so far and see if there's kind of maybe some leading questions up to that.
I know we have.
There's an ABI question. Yep, exactly. It's using the ABI. So when a smart contract is compiled, what comes out are artifacts. You've got an address and an ABI, and within that ABI, it tells you all the functions that you can call on that smart contract. So that's what we were using there. Yep. And guess what? Scaffold-eth is going to do the same thing. So here's a good transition into scaffold-eth. Scaffold-eth is a dApp prototyping tool. It's a freestanding dApp with Hardhat for your backend and React for your front end. And it helps you quickly prototype apps that folks can use. by first kind of like tinkering with Solidity and getting a feel for it, and then eventually deploying an app. And we can do that here pretty quickly. And I think I'll just dive into it. I don't see any reason, any Q&A.
Yeah, is
Go
there
ahead, Dan,
any
if you're gonna say
questions
something.
in general from the crowd? And then maybe while we're waiting for some questions to pile in, if you zoom in just a couple of ticks, it might be good
Yes,
for the
for
stream.
sure. You're gonna need to see. Yep, how's that? Let's get a little bit better here. Let's go. Okay.
It's definitely readable for there and here.
Okay. So Ethereum is our decentralized platform. We're talking about smart contracts here. We're building apps that are backed by smart contracts. What are the gotchas? What are the things to learn about this network? What works well and what doesn't? I think a really fun analogy is to talk about redundancy, first of all, right? We could go back to eth.build to even do this, where we saw everything all around. When you were a Web 2 dev and you thought about, I have a service and people are using it, and then all of a sudden that service starts to fall over, you scale horizontally, you spin up a couple more boxes, right? In this case, though, the redundancy is the thousands of nodes all across the network. They're running a very simple EVM, and you are deploying to all of those nodes. When you deploy your smart contract, it doesn't go to like one of those machines, it goes to all of those machines. And when you update a single value in your smart contract, it's actually an expensive transaction because it has to get mined into a block, and all thousands of the copies of your smart contract across all those nodes all have to update that value. So just thinking of redundancy, first of all, these apps that you're going to build are going to be hella redundant. Like, they're going to be always on. They're probably going to live longer than you are in some cases, right? Hopefully not, right? But it's kind of a dark thing to think about. But if you build a smart contract correctly, it should outlast you, and not even you should be able to stop it. So let's like kind of use that as our starting spot. Let's get in here and just like tinker with some code, and I can provide some more Web 2 analogies as we go too. But here's the dev loop. So if you want to learn Solidity, and I'm guessing people are starting out there, you're probably getting into projects and learning it. The best way to learn Solidity is sort of kind of just like tinkering. If you're a decent developer, you should be able to pick it up very quickly. So I'm going to do Solidity by example. It's more about the gotchas and kind of some of the weird things that you pick up along the way that are more tricky than the language. The language you'll understand like very quickly. For instance, let's just like dive in and look at primitives and data types, Boolean, uints, addresses. So addresses are a little bit weird, right? Normally you don't see that kind of pasted in like that. You would see maybe quotes around that somewhere in most pieces of code, but an address is kind of like a first class citizen here. Let's paste him in here. Watch what happens. So I'm just going to paste that address in. So we have an address it's a public address named ADDR, I guess, and we're going to yarn deploy that. And what's going to happen is our front end is going to detect that we've added this new memory here, and it's going to show that address there. So there it is. Let's go ahead and copy our address and set it there. Maybe even call it like owner or something like that. Okay, there we go. So now we've got we're deploying a contract, and it's keeping track of some arbitrary address, and now it's our address, and we're calling it owner. So you've got all these primitives and data types. You can write your Solidity quickly. You can tinker around here using Solidity by example. Can I paste this into the chat? Start with Solidity by example and paste that into scaffold-eth as you go. Scaffold-eth takes a little bit to get it set up. You have to have yarn and some other things. But once you're set up, you can get in this dev loop where you're just like learning new concepts quickly. Let's say a mapping is next, right? Let's go learn a mapping real quick. So we're going to bring in a mapping. You know, what does this look like? It's a mapping from an address to a uint. The kind of gotcha here about a mapping is you can't iterate through a mapping. So if you wanted to do votes, you would need to keep track of like an array of structs or something like that. So let's just do balances, and let's go ahead and deploy that. And now our app is going to be now keeping track of some kind of balances, right? Each address will have its own balance. If we copy our address and paste it in there, it's a balance of 0. And let's dive into the constructor, and let's set balances for the owner equal to like 100 or something like that, right? Let's redeploy again. Notice I'm just like deploying contracts over and over again here. It's because we're on our local network. It's super cheap. I'm iterating quickly and just trying to learn things. Now, if I go here and I paste this in, hopefully, woo, our address is 100, right? Okay, here's the next gotcha that's a little bit weird. If I wanted to set my balance to 0.001 or something like that, if I wanted to use a decimal, right? That's not going to work here. I can't do 0.01. The compiler is going to yell at me. It's going to say something like, we don't do floating point math. The EVM doesn't mess around with decimals is what it's going to say. Yeah. So the reason there is the EVM needs to be super simple. It doesn't want to F around with floating point math. And if you make your EVM super simple, it's easier for folks to run, and therefore it's more decentralized. So you kind of have to weigh this kind of pros and cons of having a more complex EVM versus having the developer experience and some of the other things be a little weird. And so in this case, we're kind of, the developer experience is a little weird because we can't use decimals here. So what we end up doing is we say this is 0.001 ether. And what that is just sort of arbitrarily multiplying everything by 10 to the 18 or dividing, depending on which direction you're going, right? So if I save that and I deploy that, now I'm going to have some kind of like decimal balance, but really it's a lot bigger than what it was before. Yeah, but it's like, it looks like that, right? So 0.001 ether ends up looking like this when it goes to way. And if we can do an ether to way just real quick to show that off to make sure folks see it. If I do, yeah, so basically that much way is 1 ether, right? Oh, I probably need to zoom in there. That much way is 1 ether. So that's another gotcha here. As you're writing smart contracts, you will have to do things like adjust things from ether to way and just be just cognizant of what's going on there. Another thing is fractions. I'll do a fraction in a second, and that'll make it make more sense. Yes. Yes. So Remix is great though, but like this is easier than Remix and it's a little bit smoother, but Remix is actually easier to get set up because it's like right in your browser. Scaffold-eth takes like 5 minutes to get installed, but you get basically a Remix-like experience in Scaffold-eth, but it's going to be like 2 more commands and we can deploy this thing to production. So you're basically prototyping and you're preparing yourself to have a product. So Remix works great, but if you're at all thinking that this thing is going to eventually have a front end, go with Scaffold-eth just because you can get the same Remix experience, but you can have this thing ready to deploy to production faster. Okay, let me just do a couple real quick things that are like super powerful within Solidity. And one is just like writing a require statement, right? It's like an assert. We're testing to make sure a condition is true. I'm going to say message.sender needs to be equal the owner, or we're going to fail. So we're going to write a rule that says only the owner can get in here and call this function. So we have some string purpose that we're keeping track of, and we have some function that lets you update that string purpose. And now we've added a new require statement, a new rule that only the owner can set it. So let's go like now test that in the front end, right? We've kind of written our contract. Let's make sure it works the way we want it to. So we'll grab some funds from the faucet and we'll set our purpose to hello world. And hopefully this will go. There we go. So we're interacting with our contract. Now, how do we, that was the good guy, right? That was the happy path. How do we bring in the kind of the bad guy or the attacker, right? The adversarial party. So green guy over here, we'll get them some gas at the faucet. Now, hopefully if this person says hello, this should fail, right? And there we go. We get a nice like not the owner message. So we were able to come in with this wallet, and that's the owner that we're arbitrarily keeping track of. And that owner is able to set the purpose. But then over here with this kind of attacker wallet, we're not able to set the purpose. And that's another thing that Scaffold-eth can do really nice is it kind of has these burner wallets. So notice I don't have, I can connect wallet connect now, but right now I'm just using a burner wallet. Watch it. So see that green and blue guy? I'm actually going to close this and open up another incognito window. It'll be a new address. It's already gone. It's already destroyed that address, and we're on to another address, right? If I destroy that one and bring up another one. So these are very ephemeral burner wallets that are being generated in your browser, but they make it so much easier for you to like test things and play around with, okay, I need this attacker address, right? So burner wallets are super handy, but eventually you're going to be able to connect in and use MetaMask and everything. So don't worry about that. We'll get to that in a second, but you don't really want to mess with MetaMask until you get to like a public network. Right now, we're just kind of tinkering with our Solidity. We're learning how we want our contract to work. And we're kind of even like kind of feeling how it feels on the front end. And, you know, like I make this transaction and then this transaction, how's this going to work? Like, how am I going to make this UI work? And eventually you'll end up like building an example UI where you can set the purpose here, hello world. Oh, didn't spell it right. And it's like attract React component. And when I hit set purpose, it calls that same function. And we still see that update and that works. So eventually you'll build out like a full-on app. But for now, we're just kind of like tinkering with our smart contract and writing things. Okay. Any questions yet? I think we're good. So I just want to iterate and kind of increment on like product thinking a little bit, right? What we've built so far is basically like an attestation machine. Only the owner can get in, and only the owner can set the purpose. And that's like very centralized in a way. Only that one address can set that, right? So if I comment that require out and we change this around a little bit, and this is the mentality you want to have when you're writing a smart contract, is you want to think of this thing kind of like a vending machine, right? You want to think of this thing as a vending machine that anyone can get to at any time, and you want to write the rules correctly so people can interact with the vending machine correctly. So I'm going to say this is a payable function, and I'm going to check that the message.value is greater than or equal to, I don't even know. I was going to use this guy's balance. Like these balance are confusing. Let's clear out the balances just because it's confusing. We should have done a little transfer function is what we should have done with those balances. But what I want to do is I want to set, let's just do 0.001 ether at first, right? So basically we're saying anyone can get in, anyone can access our vending machine and set this string, right? If they pay 0.001 ether. So now we can, pick up attacker guy. And this is a lesson to learn here is attacker is everyone. Everyone on this network you need to think of as adversarial, right? It's a trust minimized network where you only have to trust the code and everyone is a jerk. and everyone can still cooperate and coordinate because all they have to do is trust that code, right? So here we go. We have this kind of dark blue guy get in there. He says, hello world. And if he pays 0, it's not going to work. It's going to say something like not enough, not the owner. We don't want it to say not the owner. Let's have it say not enough. It's worth, well, not even spelling it right. There we go. Not enough. Let's deploy. We'll redeploy the whole contract just to have the word correct. And if I go over there now and we go try to set hello world, and we don't pay for it, let's say 0, it should say not enough. Yes, it did. Okay, but if this guy is willing to pay 0.001 ether, of course you can set the, oh no. Okay, ETH first way. So we have to do that one thing, right? I can't send 0.001 ETH into the EVM. And normally when you build an app, you would definitely do this behind the scenes. But since this is for a developer, I kind of force you to take it times 10 to the 18. So you have that moment just now where I thought I was going to get away with posting 0.001 and I actually need to take it times 10 to the 18. So I, as the developer, understand what's going on there. Now, when I send that in, there we go. I was able to set it to hello world. Let's see that again. Hello, and send it again. And we pay some money. Now, something really interesting is happening here. This smart contract, every smart contract that's deployed has its own address too. And it's sort of earning value, right? The smart contract is up to $6 now stored in the smart contract in the vending machine. And what we forgot to do was write some kind of withdraw function, right? Back here, we probably should have some withdraw function that says, if I'm the owner, it allows me to withdraw the funds or something like that. You should definitely build your vending machine so you can at least, withdraw. And sometimes that's not good, right? Sometimes you want the money to stay in the vending machine because it's a DEX or something where it has reserves on both sides and people are swapping between tokens. So the code is law here. That's kind of a loaded statement too, but really like what it comes down to is trust, right? What we have to trust is this code. And if you write the code nice and simple and clean, then people who interact with your vending machine only have to trust this code, and this code's going to do what it's going to do. So you as the developer can quickly innovate. You can really like move quickly with just like ideating on what we're doing here. Let's make a uint 256, and we'll call it, it'll be public, and we'll call it price, and we'll set it equal to that 0.001 ether. Okay. And we'll make sure that someone pays the price, right? But we're going to add one more line here, and I'm going to do something. I'm going to say price equals price. We're going to say times 1001 divided by 1,000. Okay. And remember, we couldn't do fractions earlier. And this is what I wanted to show here. You can't, it's another gotcha of Solidity. There's no fractions here. So if I want this to go up, actually, I think if I want it to go up 1%, it would be that every time, right? And I could do something like that. Anyways, what we're going to do here is we're going to let anyone set the purpose as long as they're willing to pay. And we're going to charge them 1%. And the price is going to go up 1% each time we charge somebody. And let's go ahead and deploy that, and let's make sure it works. How are we doing, Dan? Good on time and everything?
Yeah, I think we're doing great. We're
Awesome.
just about at the hour range. And I don't know about you guys, but this has been fun to watch the rapid development. And like reflecting on kind of what we're seeing here, is that we can really basically manually fuzz what our logic is and our ideas. So you're rapidly saying, here's my contract, and I'm just focused on the Solidity aspects, and then immediately you have this front end to tinker with it, right? As opposed to like, the typical hell of just using print statements and things to diagnose bugs and stuff.
Console logs,
right? It's like, now we're actually, let's get a GUI that immediately is populated with all the things that we can tinker with and play with it. One thing I wonder though is how much this isn't a replacement for actual fuzzing and auditing. So when you're ready to like actually go to production, this probably is not the right tool to like claim that you're secure and safe because you tested all the functions on scaffold-eth. Right.
No, this isn't for like knowing the thing is safe. This is for learning how to build it and knowing that the thing works, but you still need a professional like us. Like writing smart contracts is easy, right? We're making progress on this smart contract over here. Writing a secure smart contract system is incredibly difficult, and auditing takes, it's so much more, of course. But in terms of like being able to build something that people can use and we can go to production, like we could go to a small value test net. Like I could go live with something in 15 minutes, and like I could deploy it and be like fairly confident that it's going to do what it's going to do. But obviously, if you're talking about millions of dollars staked into a contract, you need to audit the heck out of that thing and take time to do the due diligence on it.
It makes sense. I think in the context of this class, right, we're building out some minimum viable dApps to go and showcase what we can do. So deploying on a testnet is something I hope that everyone in the class aspires to do with their dApp. But at the same time, realizing that audits and things are not in the context of this class, probably keep in your mind that this is something you should be thinking about. And if people are doing their jobs, those adversaries on the other side, even on testnets, they might come and dink with whatever you're putting up there and totally screw it over. So it's a fun place to go and check things out.
So leaning back on Solidity by example, I'll just keep building some things for a little bit. When you send ETH, I'm just going to pass this along. You can use transfer and send, and a lot of people do, and I do in a lot of my code. But something has come up recently where it doesn't work when you're sending it to like a Gnosis safe because it needs to use gas and it has a fallback function and there's all this other stuff. So I'm going to set it up to send. What I want to do is not have money locked in this contract is basically what I'm trying to write here. And what I want to do is say when money comes in here, I'm going to have some beneficiary called the owner, and I'm going to send them all the value or revert. Okay, that should work. And I could delete this and save that. Let's see if this works. Basically, I'm going to push this to production right now. And I just didn't want to have money locked up in it if I actually put it on mainnet. So yeah, okay, there we go. So that is going to deploy. Let's see. So this guy's going to be the owner. The price is set at this at the start. When it first gets set, basically we created a price curve by setting a price function and then adding this one line right here. We created a price curve. Now the price goes up by 1% every time someone says something. But notice the money is not loading up in here anymore. It's actually going to this account, right? So I just added, like one more line of code, and it kind of does something totally different. Let's come in as an adversarial party, and let's pay money, and let's make sure it goes to my account. And if that all works, let's deploy this to a public network, assuming that it's sort of secure, but not $1 million secure. Like I want to lean into the fact that like people should be trying things, but of course you need to be safe and you need to audit things, but don't be like afraid at least to put these on a test net. Like don't be afraid of putting stuff out there. It's sort of like the folks that should be afraid aren't, and the folks that should be like doing more stuff are too afraid. So you have to be careful with like, yes, this is super scary, but it's not that scary. Get out there and try it. So what I'm going to do is he has $29. I should be able to go here. I should be able to say hello. The purpose should update. I should pay, up the curve. I'm up the curve a couple steps now. Money should not go into the contract. It should show up over here. This guy should receive the money. There he did. Okay, there we go. Okay, so no, this isn't ready for mainnet millions of dollars. Yes, this is probably ready for Austin to YOLO to some public network, and we can try it out. So let's do that. Now, of course, you would spend more time on your UI. You would get buttons looking right. You would use these events to create something looking nice. You would not give your user this interface, but let's just assume that you spent some time in React and you spent some time making this thing look pretty, and someone can come in here and type in some purpose, and you automatically calculate where they are on the price curve, and you charge them that much. Let's pretend like we have that front end built. The kind of the real innovation happened here at the Solidity level. But once we're ready, once you have that sort of idea and you want to share it, I want Dan to get in here and I want Dan to use it and I want Dan to experience it with his wallet. How are we going to set that up? Okay, so let's do a mainnet deployment, or maybe not mainnet. What's gas at right now? It's not bad. we could let's go to a test net, just like good security practices. I shouldn't be YOLOing to mainnet. So what I'm going to do is I'm going to do a yarn generate. Now, just like our mnemonic back over on eth.build, I'm going to create a 12-word seed phrase just for this deployment. This is good OPSEC. Instead of me copy and pasting some private key or mnemonic in, I'm going to generate a new one, and then I'm going to send just enough to this address to be able to deploy to Covan or something, right? We're on Covan. Let's just send him a little Covan 0.01, something like that. And there we go. Okay, so our deployer has a little bit of Covan. Now I'm going to do a yarn deploy -- network Covan and go. We're deploying to a public network. Here we go. It should take about 5 seconds, but if this was mainnet, it would work the same exact way. It would take a little bit longer. It would cost a lot more real money. Let's see, 500. Let's see what that would cost on mainnet right now. I feel like I have a little gas calculator here. I don't see it. I have a little gas. Oh, here we go. Gas calc new. Let me bring this in. So another handy eth.build sandbox is it looks at the current price and that limit. So that would cost $107 right now. If I deployed this contract to mainnet, it would have cost $107. Not bad, but probably not worth the demo. Like that's you guys are college kids. $100 probably goes a long way. Probably not in Berkeley, but where I went to college, $100 went a long way. Okay, so our deployer has money. He's deployed to and we could even go to this like. Our contract is now on Covan, right? We could go to covan.etherscan. We could go to a disinterested third party, and they would say that it is not actually deployed. Maybe Etherscan. Did I do Covan? Okay, so maybe we're waiting for the contract. Here's the transaction hash. Let's see if we can even find that. Oh no. I'm just gonna assume that actually like Covan Etherscan is wrong and my stuff is right, but probably not. But here's the other change. So basically we deployed our contract to Covan. Now what we need to do is change our front end to go talk to Kovan. So you'll go to your React app. Usually you'll spend a lot more time over on the React side, getting your app working, making sure people understand. But I'm going to just like make a quick change here. Hopefully, let's point this at Kovan. Is Kovan behind? If we go look at like just Kovan Ether scan 35 seconds ago, I mean, they're throwing blocks out there. Okay, so I'm going to change my front end to be on Kovan. I'm going to hit save, and hopefully we should get our contract. Let's see what happens here. Yes, it's there. Okay, so it is out on Kovan. So all I did, this front end is all created for me. It's ready to go. It was pointed at localhost. I changed this one thing, and now the entire app is switched over to Kovan. If I click my address, it's going to take me to Kovan Etherscan. If I click that, like these addresses are all, oh, that one didn't work. These addresses are all wired up to go to whatever network you're pointed at. So it's we're rapidly prototyping. We're going to Kovan for a little bit. Okay, well, let's go to an L2. Let's deploy it to Optimism. It takes a couple settings, and then your app is over on Optimism, right? So I'm actually going to do a yarn build. I'm going to get that started. But let's go try to make a Kovan, actual Kovan transaction with our MetaMask, right? Now it's time to connect MetaMask. We're on a public network. I'm going to say hello world, right? Classic. Grab the current price. So I'm going to pay $2 on Kovan to set this. And now there's a price curve, right? The price is going to go up 1%. My value is going to get set. We're using, and now we have a nice like kind of notification system from Block Native. Things are feeling a lot more professional. And we're just like, 5 minutes away from we were just tinkering and kind of figuring out, kind of doing that remix kind of feedback. And this is where this is really powerful. It's like, this gets your prototype out the door and it gets it into people's hands so people can try using it and you can figure out like, is this going to work? Is this UX going to work? Will people go through the UI? Let's see. There's a question here. Let's see something about. Oh, you're saying it takes a while for a transaction to get. Yeah, I think test networks are probably just a little bit slower. There's probably more latency out on a test network just because there's probably a lot of noise and people messing with it. What is it, Doc? Best? Yep, go ahead.
I was going to say, we have a question on just how do we learn more about this, and specifically scaffold-eth.
Yep. So I've prepared a curriculum. It's super easy for you to learn. Are you ready? Here's the meme. You need to speed run Ethereum. So if you go to speedrunethereum.com, I'll paste that into the chat here. Oh, maybe I will paste that into the chat here. Boop. Speedrunethereum.com is basically, I started like 2 years ago doing like one-on-one mentorship sessions where I would just get on with anybody on a Zoom call and we would go through their questions back and forth. And after a while, I realized like, okay, like this is resonating, this isn't resonating. And I created this curriculum so you can go through and take on these challenges at your own pace, asynchronously, and kind of get the mental model that you would get if we were like on a call rapping about stuff, but you're going to kind of like learn through how things work. In particular, like challenge number 1, talking about the superpower of Ethereum, allowing you, the builder, to sort of like create this set of rules and let an adversarial group of players use it without being able to grief each other, right? Like a bunch of people that don't trust each other can coordinate financially to make something happen. And that's like one of the superpowers of Ethereum. And it's challenge 1 in Speedrun Ethereum. And so Speedrun Ethereum is going to get you, get scaffold-eth. Obviously, you can just like start with just like tinkering with scaffold-eth. You definitely want to like follow this README and like learn the curriculum, learn all these different topics in Solidity by example. But really, like Speedrun Ethereum is the place to go. If you have like a boring Thursday night and you need to like fill it with an hour, go Speedrun Ethereum, go take on these challenges. On the other side of these challenges, you'll have like the mental model and the tooling to just like really tinker and kind of create the products. I'm assuming a lot of folks already kind of have that, but this will help you kind of get there. Okay, our site is ready. I'm deploying it now to Surge. What was it? It was a kind of like a price curve. Oh, look, I've done this before. A price curve perp. P-U-R-P. Have I done this one before? Let's see. Nope, it's going. Okay, so we went from I've got scaffold-eth and I have a template contract to I'm tinkering and I'm thinking about writing some rules, to I'm building the smart contract with a price curve and I'm sending money out of it, like a few quick innovations. And now we have like a live app that is on. You guys at home and in the classroom can go to pricecurveperp.surge.sh, and it's going to be an app on Kovan, and you can connect your wallet and you can get in there and say hello world and pay a little bit of Kovan ETH to do that. And so this is what I'm talking about, is like you can rapidly prototype and you can get something in front of your friends and get them to like use it and see if it's going to work. So I'm going to say hello. I'm going to say 2, and I'm going to pay the 101. But someone out there, take a chance, hook up your Kovan wallet and set the purpose on this contract for fun. It'll change it on my screen too. So don't write anything dirty. So, okay. So next steps, speedrun Ethereum is probably the obvious next step here. Another next step is just like, as you get through learning a little bit about scaffold-eth, you're going to find that it's like a really quick starter kit. And a lot of other people have used this starter kit to make new starter kits. So if you go into scaffold-eth examples, I'm just going to go to this specific, I'm going to go to branches and I'm going to go to active, and I'm going to paste this into the chat. So I have this whole kind of incentivization layer called the Build Guild, where people who are forking scaffold-eth and making cool things, I'm streaming ETH to them. So there's all these folks that are sort of incentivized to build these cool things. Like, how about a token multi-drop? Like, DAOs need these. There's so many DAOs that need tools to do things like dropping tokens. Here is Bliss creating a token dropper, or a multi-sig. Like right now, there's not a lot of great competition in the multi-sig space. Like there is one multi-sig, and sometimes it doesn't work very well. Like we need more competition. We need more product people thinking about building products in the space and building like good products that people want to use. A ZK game, right? That's going to be super hot this summer with L2s coming on. L2s are on, but people adopting L2s and deploying games. Games don't work very well on a public deterministic blockchain. Like it's hard to build a game on a public deterministic blockchain. And that's where ZK Tech will come in. And like Brian Gu and the folks at Dark Forest are really leading the way on a lot of that stuff. All these branches of scaffold-eth, it'll get you dangerously close to having what you want to build if scaffold-eth itself doesn't get you that close. But hopefully scaffold-eth is a good starting point. Speedrun Ethereum helps you get the mental model, and then all these branches are nice and forkable and available for you to try them out and check them out. So where are we at? What kind of questions do we have? We're totally open now. I've just kind of let it roll and answer some questions or whatever the vibe is.
I think first some applause, man. This is great.
Thank you.
Yeah.
Okay, cool. Thank you.
Thank you for
Awesome.
the audio.
Amazing.
That was
Rock on. Yeah, guys, I think we should turn it over to general, like, ask an expert. If anybody knows some great places to learn more, I think Austin is the, like, going to be pointing you in all the right directions. So if you have burning questions about Ethereum development in general, and it could be what we talked about tonight or even more advanced.
Yeah, Dan, we have one question so far in class. You want to come up and ask? For sure.
Yeah, get
Barely.
up in front of the,
barely. I could almost yell it out.
whoops. Sorry, let me bring him back up on stage. I meant to bring him
Did we
full
kick him
screen on
out?
stage. Hold on. Pin. I want to pin you.
Your example
Sorry,
with the,
now we're online.
with the soldiers. Your
Yeah,
example with the soldiers
Yeah.
And with the generals, and I guess that's the process of authentication or mining. Is that right?
Yep. That was like showing proof of work.
Yeah, proof of work. So you set that up, I guess, in a kind of like a purely kind of programmatic model. Is it possible to involve some kind of participatory feedback in the proof of work process? I'm wondering if that could be kind of like, if you could show us, like if you need somebody to authenticate something in order to generate, in this case, a token, or if you hypothetically needed to, you know, get data from a location or a group of people with keys to kind of combine their keys in some way. Is that kind of thing reasonable or even
There's a lot going on there in that question, and I can kind of bounce around through a few things. One thing you talked about was like an oracle, like getting outside. Wait, can we hear me? Are you good? Are we good? Yeah.
Yeah, we're good.
Oh, okay.
Yeah,
So one thing you talked about. Okay, so one thing you don't want to do is like be relying on one person, right? Like that one account thing is really scary because that's like very centralized. What if that person like dies or something, right? You're thinking of like, you want these systems to live a lot longer than any of the single humans that are sort of like coordinating them. Another thing you said there is outside data, and that's like the Oracle problem. If you look at like Chainlink or some of the other services in the space, their job is to find a way to come to consensus about off-chain data and have it land on-chain. And that's a super tricky, hard thing to do, because if you just have one machine that's bringing that data in, then it's super centralized. It could get manipulated. You're only as strong as your weakest link in a lot of ways. And then you said something about like having people get together and combine their keys and then have them connect. Like that's kind of fun. That's a fun little mechanic. And I think that's one way that I think people use to back up their mnemonics is they'll have 6 words in one place and 6 words in another place. And you put those 2 6 words together to get the 12 word to be able to get in. That's still like, what if you lose one of those, then it's gone forever. Like there's in terms of like it being a cool game mechanic, I think that's a lot of fun. In terms of it being like a great way to back something up, like you want to be very careful. And in the long run, I think what you want to use is a smart contract wallet, and you want to program into that smart contract wallet, if this account doesn't check in once every 6 months, then move all the money to a colder place. Or this account is allowed to move money, but no more than $100 a day. Or if we want to move money out of this account, you need to have a signature from A, B, 3 out of 5 of your family participants or something like that. I didn't totally answer the question like head on, but like maybe we danced around a little bit more, or maybe you want to dive in.
Can I follow up?
Yeah.
You kind of follow just to kind of clarify it more, like, and I think you did kind of answer it, but let's say, for example, like Bitcoin has a proof of work, but it's a mathematical model, which then computers have to go through a process to generate coin, which then uses a lot of energy, for example. But let's say you wanted to make a proof of work that was related to some kind of cycle in nature or something like that. A coin or a token that happens every time, you have something like a full moon or whatever it might be, or a particular tree blossoms in a particular place. I'm using examples, but you get the idea that produces the token rather than the mathematical model. But it's more of a contextual data collection system, which then fits to generate the token. Is that kind of thing possible?
I'm not sure. So probably yes. I'm not sure like how valuable that is in terms of like the reason why proof of work is so valuable is like at like a globally competitive level, it is a scarce resource, right? And like people are like that the fact that it is like globally a scarce resource means that no one person can control it. And in terms of like, if we gave you a token every time this tree blossomed, there's still going to have to be some kind of oracle that's putting that information on chain. But what I think we're kind of leaning toward here is where Ethereum is going with proof of stake, and they're pulling out the proof of work mechanism, and they have a new like proof of stake mechanism where I have this machine here and it's a validator on it'll be the new Ethereum chain, like it's on the beacon chain now. And I'm staking 32 ETH, and I'm attesting to things. And every once in a while, I actually like verify a block, and I get rewarded for that. But it's a different system. It's not proof of work. It's proof of stake. If I do something wrong, my 32 ETH can get slashed. If this computer were to go down right now, it would like slowly start to bleed funds. But this will be the new consensus. Like this will be the new consensus layer of Ethereum in 6 months probably, and it won't be using all the energy that we're talking about. So there is like a move to proof of stake using this like well-researched, like gigabrain, way beyond me kind of protocol, and that will not use all the energy that we're talking about. Yeah. Also still dancing around the question a little bit, but the tree blooming and stuff is an interesting thing to
I guess it would have to be like you take a picture of the tree.
Yeah.
You know, then, which would make it a scarcity resource, you know.
Yeah. You have to find the scarce. Yeah. It's fun to play the game of like what scarce resource can we use and how do we like verify that scarce resource. Cool,
guys. Any more questions from the class? So I guess if there isn't anything directly, oh, sorry, what was there?
Yeah, I was saying, think we're good in class.
Yeah. So Austin, I'd love to pick your brain a little tiny bit more with the last few minutes that we have here around. So these guys are prototyping stuff, and they're going to potentially be using your tools, you know. And if they want to really impress people, like in the context of this class is effectively a hackathon, right? We'd like to be able to build something that's impressive in the end. Where can they go to look to figure out like what is pushing the boundaries in the industry that can really make some impact that you would suggest? Like, where do you go to look at like what's cool in the industry and what's needed in the industry?
Yeah. Yep. I have this tweet thread. Let me see if I can find it. Basically, it's like, yep, here it is. Web3 next steps. Let me just like pull it up and we can kind of go through it just because it's some interesting stuff that we can go through. So basically I say like you've crushed those first challenges. You can build, you know, a simple NFT. If you've gotten through speed run Ethereum, let me find it again. If you've gotten through this, you can deploy your own NFT. You can build a staking app. You can build a token vendor. You understand contract to contract interaction. You understand some of that stuff. What are the next steps from there? And I say basically like build like an executor contract. That's not that cool, but it'll help you like learn about call data and a lot of other things. Then build a multi-sig. I said like there's not great competition for multi-sigs right now. Like there's one multi-sig that everyone uses. There needs to be more competition. There needs to be like better UX. There needs to be just like a better multi-sig that works every time. And we're like 5 years into building multi-sigs, 8 years into building multi-sigs, and it still doesn't work sometimes. Mm-hmm. So a good multi-sig, learn about dexes, learn about price functions, learn about liquidity, learn about how like liquidity tokens work and how you can go way deep into the rabbit hole of DeFi, but it really comes down to like lending. And once you're lending, you're earning some yield from that, and then how that like the mechanics of that works, where like impermanent loss and all sorts of other weird things. But DeFi is a weird place to play around. SVG NFTs are really fun right now. Like basically having the contract itself craft the SVG. We made OE40s for Optimism. So on Optimism, it's OE, so it's optimistic ETH. So we made OE40s. You young college kids don't know anything about OE40s, but you can actually like I can call wrap and unwrap on this contract. I'm actually going to pay $1 here and like make the transaction, and the NFT itself is actually being rendered from within the smart contract. So I'm going to make a call on the smart contract telling it to unwrap my NFT, and it's actually going to change the way the NFT is being rendered from within the contract, right? If I unwrap it here, it is going to cost me like $1 to do this too. But now my NFT number 419 should unwrap. There we go. And we can see the liquid is there. So now watch, I'm going to make a SIP. I'm going to call SIP on my OE40. And I'm going to, we should see the liquid level go down, right? It's like right there. There we go. You see the drink go down. Now, something else interesting happened here. We built this NFT so it issues an ERC20. It issues Buzz token. So as I take a sip from my SVG NFT 40 and I see the liquid actually go down, like it would go down on the marketplace. If I was, let's look up 419 on Quixotic. So let's go to a marketplace and let's go find these 40s, and let's go look up 40 number 419. And we should see that the liquid level is probably at the old liquid level. Oh, so it's still wrapped up. You need to do a refresh metadata. Oh, there it is. Now it's down. So there on the marketplace, you can see that I've taken a drink from my 40. I've earned some buzz. Like there's just a lot of like really fun, composable, neat things that are happening in the NFT space. Also a ton of garbage. But there's some innovation that's happening at the smart contract level on NFTs that's really exciting, and composability of NFTs where we have these optimistic loogies. So you have so these are also SVGs. I did this like really simple. It's just like a circle with a color and gave it eyeballs. Like it was the friendliest thing I could make in the most simple like way with an SVG. But you can upload. I can mint these. Let me see. Let me connect. Let me mint one. So I can mint an optimistic loogie for 0.01 ETH or whatever that is. And this is on a price curve built by a scaffold-eth developer named Damu. But now I've just minted that one. If I go to fancyloogies.com, totally different website, also built with scaffold-eth. Now I can upgrade my loogie to a fancy loogie, and I can buy a bow tie NFT, and I could put the bow tie NFT on my loogie, and I could buy a smart contract, or I can buy a contact lenses NFT. Let's see if I can get in here. So SVG NFTs, I guess that was a long-winded way of saying SVG NFTs are neat and also a cool way to play around. Make sure you're solid on IPFS, Merkle tree distributions. I think you guys have talked about some of that. ZK Tech is super hot. You guys are in the right place too. You guys have all the gigabrains around you that know a lot about ZK stuff. Like ZK gaming on L2 is going to explode. If not this summer, a little after that. But like, be there, be the one writing the game. And blockchain games are hard. Like, what makes a good blockchain game is a good. Let's see if I can find that.
Can you throw some of these tweets in the chat too, so we can
I want to go find this one from AVSA. So the TLDR is that you're not going to have simple. It needs to be a good game at first, right? But you need to explore what makes blockchain unique. You need to understand the limitations. You need to understand that it's a persistent, always-on world, and the players are going to own the game. Instead of creating a giant game, create one little element of the game really well, like the loot bag where you can see the loot inside of it and it moves, and it's like the inventory system, right? In Web3, your identity and your inventory follows you from site to site, but no one has built a great game inventory system yet, right? A game inventory system out ahead of L2 summer could be something very valuable. Mm-hmm. Embracing bots is another thing here. You're going to understand that this is going to be open source. You're going to have lots of plugins. It's funny, like seeing this tweet. This tweet came out a long time before Dark Forest, but Dark Forest has sort of proven this now. If you go play the game Dark Forest, it's wonderful. But it's sort of proven what makes a good blockchain game. Okay, let me go back to that tweet where it's you've finished the challenges. Let's see if I can find it here. Yes. I think it's here. Let me paste this into chat. Basically, like you finished the challenges and now you want to continue on. There's that tweet. Let's see. LP tokens, SVG NFTs, ZK games, dice games. Like randomness is super hard on chain. You can use commit reveal. You can use VRF. But just in general, like building a good system with randomness is really tricky, and you need to understand like why that is. Another thing is just like infrastructure. If you're a DevOps builder, your skills will translate directly into Web3. And there's so many needed roles for DevOps in the space, because like we're starting to get mainstream traction and these websites are just falling over left and right? Like it's incredibly hard to actually build an indexer that gives you all of the transactions for an address. It sounds super simple. It's super stupid. But if I said, go build a script that tells you all of my transactions in the last year, you would end up pulling your hair out and eventually just going to Etherscan and getting it, because it's super easy to go to Etherscan, export CSV. I have all my transactions. But if you want to talk to this node back behind me and you want to get all my transactions for the year, you have to ask it for each block, and you have to go through each block, looking at each transaction and looking for my address and then saving it, and do that for every transaction, for every block, all the way through. You have to build your own indexer to do that. So there's just like a ton of just like DevOps and infrastructure stuff that's missing, where a lot of times you go to build a big game and you end up like finding like these obvious holes in the infrastructure. Go build that stuff too. Like start building something and find like where the holes are in the infrastructure. Diamond pattern is interesting. Commit reveal is interesting. Proves to yourself that you can underflow a variable. Delegate call is interesting. Token gating and token enabling. This is a big thing. Like being able to token enable a chat, or being able to have a token vote, or being able to hold an off-chain vote that's just signature based. There's a ton of good starter kits for that in scaffold-eth. Yeah, NFTs, anything in NFTs. The auction space is really good. Like setting up an auction so it only mints just enough depending on what the market is selecting. Like going back to the market always selects the value. Like a good auction that correctly gives the artist a good amount of money for the right, like finding the market price and only minting the right amount, stuff like that. It's like it's over my head, but very interesting stuff. Understand how the graph works. Oh, whoops, I went too far there. Understand attacks, understand reentrancy. Use a Gnosis safe. Like just use a smart contract wallet. Set up yourself an Argent along with having a MetaMask. Lots of different flavors here. Yeah, that's the space. I think that's like, from my perspective, those are some fun areas to play around, like SVG
Awesome.
NFTs, DAO tooling. But right now, like a lot of orgs are decentralizing, and therefore they have to stay decentralized, and they need a bunch of tools to stay decentralized. Yep. How does a DAO pay a bunch of employees? And that's a hard problem to find. And like we're all building our own little tools to pay people. But like that is an open problem, and finding those problems and solving them and providing good products for people, or those will get used.
That's the takeaway, right? Is
yep.
you find the problems and you solve them, and you'll most likely succeed.
Go do the thing. Yeah.
Go do the thing.
Yes.
So I know we're running overtime at this point, Austin. So I want to say thank you again so much for all of this. The exploration of your tools, fantastic, and the brain.
We can do another round of applause.
Yeah.
Thank you.
This is
hearts.
Lots of love. Cool, guys. Well, thank you all so much again for being here. And Austin, if you want to stick around for a little bit, I don't know if the class wants to stick around for a few minutes. Any further questions or whatever it might be, we can have some class announcements. Otherwise, we can call it a night.
Also, I posted my Twitter in there. My DMs are open. So you can also just hit me up async too. So speedrun Ethereum, most importantly, but also hit me up in the DMs. They're all open.
That's awesome, man. Awesome. Cool. Well, I know
the attendance code is Pixel Man. Is that Kevin?
Yeah. That's our attendance code.
Gotta love Kevin.
Yeah.
Awesome.
Good. Cool.
Yeah.
All right. Sweet. Well, I guess we'll go ahead and end it there for tonight, guys. And just we'll see you again here, I guess, in your DMs, Austin, since you're offering so nicely.
Of course. Yes, my DMs are open. I own an NFT you created. That's awesome. Thank you for sending me the NFT. I collect all sorts of NFTs.
It's a fun status symbol.
Yeah. Yep.
Right. Cool. All right, guys. Well, I think we'll go ahead and call it here.
One quick announcement as well. We will going to be having the in-class pitches on Tuesday, March 15th. So that is like the next upcoming goal. That's basically like the first midterm of the class. So that's going to be on Tuesday, March 15th. We expect everyone to be 100% in person, as well as the professors are going to be flying out and coming in person to critique the pitches. So that's a very important day. That's what we're all working towards for building the startup. So good luck with that.
Rock on. Maybe Austin will have you come back for some of the final presentations and see what people are up to.
Yeah, I'd love to see them. Yeah.
Okay.
I love being a hackathon judge. Like, it's one of the most fun things about this job.
Yeah.
Getting to see all the cool stuff people are building.
Love it. Cool.
Word. Awesome.
All right. See you next time.
Okay.
Awesome, guys. And if you have any more questions, follow-ups, obviously DMs are open for Austin out there in the world. And please hit me up on Slack. Let me know if you have any further questions. And I guess we will be seeing you all again on Thursday. And this time we're going to have mentors really come in as the focus of the class. After, I believe Tomas is going to be giving us a fairly short presentation on some more of the value proposition. So look out for that. It's going to be a good one. And we'll see you again Thursday. Bye, guys.